So let's understand. So today what I will be doing, I will be discussing the MNIST dataset. MNIST dataset. So this dataset, what is the peculiarity about this dataset? This is having 784 dimension. So now, see, since this session is all about visualizing the high dimensional data, just like the way we have discussed the dimension of the iris flower data set. So you all must be aware of this iris flower data set. So this data set is having four dimensions: petal length, petal width, sepal length, and sepal width. So we all are aware of this. This is having four dimensions. Why four dimensions? Because we are having four features. So we have done this during the exploratory data analysis. Since the dimension was very low, that is 4 dimensions, it was a very four-dimensional data set. So that is not very exciting, which is okay for our exploratory data analysis. But now we want to do data visualization of extremely high dimensional data, and we want to apply dimensionality reduction technique. We want to do data visualization of extremely high dimensional data. And after that, what we want? We want to reduce the dimension of this data with the help of dimensionality reduction technique. Reduce dimension with the help of dimensionality reduction technique. So in this context, the data set that we will use is called MNIST dataset of characters. This is the dataset MNIST dataset of characters. Fine. Now, what is this MNIST dataset? To explain you this thing, what I will do, I will take you to the Wikipedia page. Let's go to the Wikipedia page and search MNIST database. Can you see the first link of MNIST database we have opened? So just see what you can see here. If you just see, look at this data set in close proximity, what it is given. This is a MNIST database, National Institute of Standards and Technology database. And this is a large database of handwritten digits. And if you look, this is my handwritten digits. This digit that you are seeing here is basically digits from 0, 1, 2, 3 till you can see 9. So all these are the handwritten digits inside this data set. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are written, and these are the sample images from this MNIST dataset. So we will be discussing this dataset only. Correct? So if you see here, what you will observe, let's see this thing. What it is saying? It is saying it is a large database of handwritten digits that is commonly used for training various image processing systems. And this database is widely used for training and testing in the field of machine learning. Now you can ask, what is this training and testing? So don't worry, we will be discussing all these things in the subsequent sessions when we will be learning about the different types of algorithms. Now, this is what furthermore, you can see the black and white images from the MNIST were normalized to fit into 28 into 28 pixel bonding box. And then you can see here what it is writing. The MNIST dataset contains 60,000 training images and 10,000 testing images. So this is very important. So this much data set we will be using for the training purpose, and this much data points, not data set, data points we will be using for training, and this much data points we will be using for the testing purpose. So you can sometimes find a time and go to the Wikipedia, and you can just study about this MNIST data set. Although I also have some other sources from where I will be telling you how you can study about this data set. Now let's come to our data base of handwritten digits. Fine. So what are those digits? Now, one important thing is that let's suppose this is one digit. Suppose this is my one digit. So my xi is basically this. Just let's suppose because my xi is a digit, so I'm telling this as my digit xi. So whatever digit we are collecting by the handwritten digit, I am calling this as a xi. And this, my yi will be belongs to one of the 10 characters. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And what is my objective here? And this each image, and since this is an image, so each image is having 28 pixels into 28 pixels. This is my 28 pixel and 28 pixel. And this is my xi, where xi is a collection of all the handwritten digits. That is 60,000 data points here we are talking about. So it is a collection of all the handwritten digits. So what is our objective here? Objective here is I need to classify the written character, classify the written character into one of the 10 numeric character, into one of the 10 numeric character. You will understand this with the help of one thing that I'm going to explain you. So I'm sharing with you one GitHub link. So in the chat box, you can open that GitHub link. Here in the chat box, let me drop one link. You can just copy that link. You can just open that link. And I'm also going to open the same link. So this is very, very interesting blog here. And this blog is called, this is a blog written on the GitHub. You can see collab.github.io. This is a blog written by a person called Kola. And this blog is written by, is supposed to be one of the best blog for data visualization of high dimensional space using this technique, two techniques called PCA and t-SNE that we will be studying in the subsequent sessions. Now, I will be following this blog, and I'm giving the full credit for all the contents here to Mr. Kola. So let's look at what this MNIST dataset is here. So this MNIST dataset is basically handwritten characters. Can you see the characters that you can see here? This is 5, this is 0, this is 4, this is 1. So these characters are handwritten. Likewise, if you can just scroll, you can see these are the handwritten characters. These are the Kola's blog, entire blog. So whenever you have a time, must read that blog. So you will get a very clear-cut understanding of data visualization in high dimensional space, how we can reduce it to low dimensional space, that is in 2D or 3D. So now let's see this thing. We know we have 10 characters and all. So each of the character is basically 10 characters. And each of the characters is basically photograph. This is basically a photograph of a handwritten characters of, or you can say it is a scan copy. All these are the scan copies of a handwritten characters written by some random guys, some random persons. So we have 10 characters or photograph that I was writing of handwritten characters, handwritten character. Fine. Now, so these are basically, it's like somebody has written this character and somebody has taken the image, or you can say scanned it. And each one of this image, here if I look at this image, so this image is having 28 pixels. This is my 28 pixel. So let me. So this image, let's say this image, if I will consider this file, this is having 28 pixel and this is also 28 pixel. So this horizontal, this 28 pixel into 28 pixels horizontally and 28 pixels vertically. This is the size of each one of the collected image, size of image. This is the size of all the images that we have collected. So, and this data set is basically, I'm telling you, this is a computer vision data set. So when you will be studying the computer vision, at that point also you will realize why I was telling you this is a computer vision data set. So likewise, like you can see this digit, handwritten this digit, this digit, this digit, and so forth. There are a lot of digits that we have already. Likewise, we are having 60K, that is 60,000 digits, handwritten digits, or you can say 60,000 training points. Training points. So we have some data for, let's say, 5. There are a lot of data for 5. Likewise, there is some data for 0. There is some data for 4. There is some data for 4, I, etc., etc. And we are given 10,000 test data points. What is this test data points and train data point that we will be discussing? But for now, let's understand when we build a machine learning model or for prediction for any data, we first train our model. So that is, we make the model understand how, make the model understand the variations of in the data point, or understand the relationship between my data points, so as to make it ready for the prediction. So we train it with the help of this 60,000 data points, and then we check the results of the training with the help of test data set that is having 10,000 data points. Fine. So you understand these things. Now we will understand all these things in machine learning algorithm. What is this train and what is this test and all these things, right? Now, if you look at this data points, let's suppose, let me give you this thing. Let me, if let's suppose if you, so if let's suppose our data sets are like D, so I can say my XI and YI. My data set will be like XI and YI. And here I am saying I is equal to 1 to 60,000, 60K. And here I have already to each of my XI is basically 28 pixels into 28 pixels. And my YI is basically, YI is belongs to 0 to 0 till 9. Fine. Now, if how we can use this, since my image data is having 28 into 28 pixels, now there is a problem. How we can convert this data into some numerical values or some real metrics form? Because until unless I'm not able to convert this data set, this thing into a numerical value, we are not able to perform any sort of algorithms having xi, comma, yi, and I is equal to 1 to 60K. Fine. And my yi is basically, my y is basically 0, 1, 2 till 9. Now let's suppose this is a image of 28 pixels into 28 pixels. Right? And this is my xi. Now I want to convert this into some form, into some vector form, so that we are able to use the my machine learning algorithms on it. So what I will do, I will, this is a 28 pixels. One image is having 28 into 28 pixels. That is, if you will calculate, if you will multiply this, we will get 784. So we say that each pixel is my feature here. That's why each image is having 784 dimension, or you can say 784 features. Are you getting my point? So whatever be the my image, let's suppose if this is my image, if this is my image, so this image, if I will make a matrix out of this image, so what I will get? I will get this 28 cross 28. This is my 28 and this is my 28. That's why I am getting this 28 into 28. Understand it. Here only one image. I'm not talking about my entire data set. I'm talking about only one data point. One data point. So one data point, that is one image, is having this much 784 features or dimension, you can say dimension. Now, this is not a, you must remember this thing is not my data matrix. This is not data. I'm writing it especially for this so that you should not a data matrix. This is not my data matrix. This is, then what this is? This is basically the matrix representation of a single image. Matrix representation of a single image. Are you getting my point? Now, so this is how you can say the image is represented internally inside my system. Now so what actually we used to do, I'm sharing you the Ola's handwritten notebook again, and then we will be, so let me share this, where it went, Ola's handwritten characters. Let me share this Ola's handwritten character. Fine. So now if this is a Ola's handwritten character, now let's see one thing that I want you to understand it well. Now this is a image of basically let me just zoom a little bit so that you can able to understand it. See this thing. See. Now, this is a image of 1. This is handwritten 1. Someone has written. And this is a 28 pixel into 28 pixel pictures generated. How it is converted into pixels that I am talking about here. How this is entirely converted into pixels. Now, if you observe something, you can see at these points, we are having 1, 1, 1, 1, 1. The value of the individual pixel, because this is 28 pixel, this is 20, this is a matrix of 28 into 28 pixel. But if you observe here, these values are 1, 1, 1, 1, 1, 1, and 1. What it means, wherever you can see the value is 1, that is completely dark, or you can say that is completely black. So since you can see here in this one, the way it is written, most of the places it is completely black. So wherever it is completely black, you will get the pixel value of 1. And wherever it is completely white, as in this case, you can see here, at these places, at these many places, wherever you can see the value is 0, that is completely white. So here also, there's complete white. And other than this 0, that is 0 represents complete white, 1 represents complete black, and the value between 0 to 1 represents how much intensity of 1 is the complete black. And whenever the value is moving from 0 to 1, the intensity of grayness or blackness is increasing. So you can observe this. You can see at these places, there is a intensity is decreasing as you move from this complete black to this side. The intensity you can observe, the intensity is decreasing. Can you observe this? Intensity is decreasing as you move away from this place. This is lagging. Fine. So that's why you can see the value is also something. Somewhere I am getting this pixel value is 0.4. This is 0.4, 0.4. This is 0.7. And again, here at these things, we are having the values 1, 1, 1. Here you can see 0.1, 0.1. Likewise, here you can see something here. So this value, which is from 0 to 1, these values, which is from 0 to 1 basically. So these values, which is from 0 to 1 basically, it represents how much intense is the blackness or whiteness that it represents basically. So I suppose this is clear. You can also understand this. Let's suppose if this is, you can understand it in this way. If this is, let's suppose this is my one image of a handwritten, this is the image of a handwritten. I can also convert this into a grid like grid. See, I will, let's suppose I have made 28 grids here. Fine. Fine. I have made 28 grids here. Similarly, I have made 28 grids here. 28 grids here also. 28 grids here. Likewise. Now, each of the grid, yes, you can ask question, Rakesh. You have raised hand.
So, like, anyway, I got disconnected for 1 minute, but still I have doubt before that. Is this something like when we scan and that's how the computer or scanner records the data? Like,
Yes, yes. अभी क्या है कि एक मैंने कोई भी हैंड रिटेन कैरेक्टर लिया, कोई भी हैंड रिटेन कैरेक्टर लिया, अभी हम लोग 0 to 9 ले रहे हैं एमनिस डेटा के सेट में, तो उसको मैंने 28 पिक्सल्स और 28 पिक्सल्स के फॉर्म में एक इमेज है। तो मान लीजिए कि मैं ये कह रहा हूं कि ये एक 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 वन है ये, तो इसको अगर 28 × 28 में ऐसे मैं कन्वर्ट करूं ग्रिड के फॉर्म में, तो ये एवरी ग्रिड इज 1 पिक्सल। आप समझ रहे हो?
हाँ,
हर ग्रिड एक
तो
पिक्सल।
ये 784 पिक्सल हो गया।
करेक्ट। तो ये करेक्ट, ये 784 पिक्सल्स हो गए। सो वी हैव 7, तो मैंने क्या किया, वी हैव converted this into 784 dimension actually, matlab this is actually having, and 1 pixel is 1 feature, 1 pixel is having 1 feature. So total we have, in every image total we have 784 pixels. So what we are saying, there is a, every image is having 784 dimensions. Are you getting my point? Because in case of machine learning, dimensions means features. How many features a particular data is having. So this particular data is having 784 dimension. Have you got it? And have you got these points? आपको ये समझ में आया कि ये 1 क्यों है, ये 0 क्यों है?
हाँ, ये समझ में आ गया।
ये पिक्सल्स, ये एक पिक्सल है, उसका वैल्यू है, ये एक पिक्सल है। जो मैंने ये जो ग्रिड है, एवरी ग्रिड इज 1 पिक्सल। तो जहां पे इसी तरह से वैल्यूज जो डिफर वेरिएशन हो रहा है, वो वेरिएशन इसके कलर के इंटेंसिटी के ऊपर वो वैल्यूज हमारा वेरी कर रहा है फ्रॉम 0 to 1।
तो ये डाउट यहाँ ये बन रहा कि अगर कोई भी इमेज का डेटा जो स्टोर होगा तो मिनिमम 784 फीचर्स उसके पास होगा, ऐसा है क्या?
अगर हम अगर हम 28 × 28 पिक्सल्स लेते हैं, तो अगर हम पिक्सल ज्यादा लेंगे तो ज्यादा होगा।
तो ये पिक्सल्स कौन डिसाइड करेगा? सिस्टम खुद से डिसाइड करेगा या जब इमेज वो स्कैन करेगा, मान के चलिए, या डेटा स्टोर करेगा तब, या फिर?
हाँ, ये तभी डिसाइड होगा। यहाँ तो हम एक नॉर्मल केस में हम लोग 28 × 28 पिक्सल्स लेते हैं, ठीक है। तो अभी हम स्कैन और वो सब के, हमारा पर्पस कुछ अलग है। हम ये कह रहे हैं कि हमारा ऑब्जेक्टिव, मैंने आपको बताया था, हमारा ऑब्जेक्टिव क्या है कि हमारे पास 60,000 डेटा पॉइंट्स है ना, 60,000 डेटा पॉइंट्स हैं, मतलब 60,000 इस तरह से हैंड रिटेन डिजिट्स हैं, जिससे मैं अपने अल्गोरिदम्स को ट्रेन करूंगा और फिर मैं उसको एक नया डेटा दूंगा विच इज ऑल्सो हैंड रिटेन बाय समवन एल्स, ठीक है, जो इसने मतलब अभी इसने देखा नहीं है, एंड देन आई वांट इट टू प्रेडिक्ट कि ये 0 to 9 में से क्या हो सकता है। समझ रहे हैं? इसीलिए when you will be studying the neural network, deep learning, neural network, computer vision and all those things, video processing, ये सब, so there क्या होता है कि millions and millions of features होते हैं, billions में features होते हैं।
अच्छा।
हाँ, तो ये तो सिर्फ 784 डायमेंशन है। देयर यू विल गेट टू नो द डायमेंशन विच इज इन द मिलियंस। सो क्या है ना कि मशीन लर्निंग वहां पे फेल हो जाता है, डेट्स व्हाई वी विल बी यूजिंग द other type of specialized form of machine learning, use so deep learning. There we use neural networks, that's why। अभी हम लोग उसकी बात नहीं करेंगे, अभी हम लोग यहीं पे लेट्स स्टिक टू आवर डिस्कशन ओवर हियर। आपको ये समझ में आया?
हाँ, समझ में आ गया।
ठीक है, अभी मैं आपको एक चीज दिखाता हूं। अभी क्या होगा कि नाउ दिस इज, नाउ one thing, okay, let me, I'm sharing my screen here, let me share the screen। अब मुझे स्क्रीन शेयरिंग बराबर में, what's actually is happening? So now if you have observed, I have told you that this is a matrix representation। So basically मेरे पास क्या हो गया कि when I have some image here, I have converted this image into a data matrix। This is basically a form of data matrix। Fine? So matrix representation of single image I am talking about. Now, how to get a data? Now, you know this. Now, from here, the question is, until unless I will convert this into a data vector or a data point, I am not able to use it in my algorithm. So this is because this is my data matrix. And this is just a matrix. I have already matrix representation of my image. So now how we can convert this particular, how we can convert this matrix of pixels into a vector? So for this, we do something which is called flattening. So flattening is, what is this flattening thing? So we do something called flattening. So let's suppose if I convert this, if I flatten this data, so I will get a single column where xi is belongs to the dimension rd, and since this is a 28 into 28 pixels, so this will be 784 into 1। फ्लैटनिंग में मैं क्या कर रहा हूं, लेट सपोज ये मेरा जो भी पिक्सल है, मैं इसको आपको बताता हूं, समझाता हूं। सो मैं पहले क्या कर रहा हूं, ये जो भी मेरा आया, इसको मैं फ्लैटन करूंगा। फ्लैटन मतलब आई विल कन्वर्ट इट इनटू आइदर ए रो वेक्टर और इनटू अ कॉलम वेक्टर। सो दिस इज कॉल्ड फ्लैटनिंग। फाइन। So let me draw some one more here thing to make you understand this. Let's suppose I am drawing one matrix here. Let's suppose this is a matrix I am drawing. Fine. Now, let's suppose this is my this thing one. This is so this is one. This is two. This is three. This is four, and this is five. So this is a again. This is one. This is two. This is three. This is four, and this is five. And let's give it a representation. This is one, two. This is one, two, three, four, and five. This is my one, two, three, four, and five. Correct? So this is my 5 cross 5. Let's suppose I'm giving some value. This is my, let's use some other color. So I'm giving, this is my 1, this is 2, this is 4, this is 6, this is 8. This is, let's suppose 3, this is 2, this is 1, 8, 2. This is a random value I'm putting here. 2, 1, 6, 8, 4. This is 3, 2, 1, 8, 2. And this is, let's suppose 4, 2, 6, 8, 1. Now, let me draw it first, then I will explain you. So let's suppose if I just do this, and then after doing the flattening, I will get a vector something like 25 cross 1. And here it is 1, 2, 4, 6, 8, 3, 2, 1, 8, 2, and so till end. Now let me explain you what I have drawn. So let's assume here what I have done. Let's assume I have this 5 cross 5 columns. This is my 5 columns and this is my 5 rows. I have, just for simplicity, I have taken this 5 cross 5 matrix. Fine. And let's assume I have a value of 1, 2, 4, 6, 8. Here I have a value of 3, 2, 1, 8, 2. Likewise, 2, 1, 6, 8, 4, and till. So I have in every row, you can see I have some numbers like here I have 2, 1, 6, 8, 4. Here I have 3, 2, 1, 8, 2. Here I have 4, 2, 6, 8, 1. Something, some number I have put it. Now let's suppose, how do we convert this into a column vector? So to converting this into a column vector, we are using something called flattening. Flattening. This is called flattening. So what we are doing in flattening, basically, I am taking each row individually and I am putting it in the column. First I am taking this row 1, 2, 4, 6, 8. 1, 2, 4, 6, 8. Then I have taken second row 3, 2, 1, 2, 8. 3, 2, 1, 8, 2. Likewise, I will put this column row also, this row also, this row also here in a column way, column wise manner. So this is basically a long vector. If you look at the image matrix, this is, let's say, if this is my image matrix of 5 cross 5. So this will be my column matrix or column vector of 25 cross 1, because here we have only one column and 25 rows. So every pixel here or every grid here I have taken in my column, inside one column. So you have understood like how I have done this. So this is called flattening, or this is called row flattening. Similarly, there is something called uh, column flattening is also there, and row flattening is also there. But here we are using this flattening. Now, when we have done this flattening, so there are 25 rows and 1 column only. So likewise, in our data set, we have this 28 into 28 pixels. 28 into 28 pixels we have. 28 horizontal pixels and 28 vertical pixels. So I can convert this into a data point. I can, which is a column. I can convert this into a data point, which is basically a column vector by using a row flattening or column flattening. Anything, whatever I do, everything is fine. Anything is right. So when I will convert this into when I will perform the flattening operation here, the same thing, whatever I have done here, if the same concept I will apply here and I will do the flattening operation, I will get 784 rows into 1 column. Understand? So each image, so we can say each image or each data point is 784 dimensions. What it means 784 dimensions? It means I have F1 feature, F2 feature, F3 feature, F4 feature. Likewise, I have F784 features. Till 784 features. So I have already explained you here what I am doing. I am taking each pixel value as a feature. That's the simplest way to understand. So here I have told you we have 60,000 data points, correct? We have 60,000 data points. Where I have written nowhere here. Okay, here. We have 60,000 data points. That is, each data point is having, each data point among the 60,000 data point, each data point is having 784 dimensions, correct? Now let's write it in a more elegant way. So what basically I am doing here, let's suppose if I write, this is my, let's suppose this is my, let's suppose 28 into 28 pixels. So this is my 28 into 28 pixel image. Then I will do row flattening here, row flattening. This is lagging, flattening. I have to resolve this issue. This is lagging today. This is row flattening, and finally what the data set I am getting is something like this, which is having 784 cross 1. Now if you observe, let me, if let's suppose I have this data matrix. Now I am writing a data matrix. Here I have written each pixel is having 784 features. So now let's suppose I am having this data matrix. So this is, what is my data matrix? If this is my data matrix, so this is having X, and so these are my features, F1, F2, F3, likewise 784. 784. 784. Fine. And this is my number of data points, 1, 2, 3, 4, till how much? 60K data points. So here N is equal to 60K and D is equal to, D means dimension, 784. And this is my YI. This is my yi. And what is my yi? My yi belongs to 0, 1, 2, 3, 4 till 9. What it means? And this is 784. We know this 784 dimension. And if this is, and this we know that this we can write it as xi transpose, where r is my real value belongs to 784 dimension. So I suppose, and this is my MNIST dataset. I am writing this in the context of MNIST dataset. So have you understood this, Mr. Rakesh?
Yes. Yeah, I understood.
So now I have a very, so let me tell you one thing. So this is a 784 dimensional data set. And we know we even struggle to visualize the 4-dimensional data set. Or when we have 4 or 5 or 6-dimensional data set, we use things like pair plot. But as soon as this dimensionality increases, even when it becomes like a 10-dimensional data set, then also we struggle to basically see visualize the 10-dimensional data set. So this is the beauty of machine learning. So what we will be doing, we will be using a simple algebra to understand how we can reduce the dimension of this 784 dimensional data set into, let's say, 2 or 3-dimensional data set. And now I will again take you to the Cola's notebook that we have gone to the starting. So let's, if I will come here, so this is, you must go through this blog. I have read this blog. So you can see, if I will just come here, if I just come at the bottom, here is something called visualizing MNIST with t-SNE in 3D. Click and drag to rotate. Why this is not playing? Okay. Can you see? This is playing. This MNIST dataset as a graph in, this is a visualization of this dataset and how it has converted this with the help of this technique, t-SNE and PCA, how he has used this technique to convert this high dimension into this something which is understandable by human eyes. Now let's see one thing. If I am going here, can you see this visualization? Can you see? If I am going here at this blue, it is showing 7. That is
Yeah.
all these blue points represent 7. So this is how they have converted such a huge dimension of data into 3D, you can say, or 2D. If I will take this to this here green, all the green points here are 4. If I can take it to this something like red, all these points are 9. If I will go here, again this is 7, this is 7, this is 8, this is 8, this is something like 1, this brown colored something is like 1. So you can see this thing here. One more thing you will notice here, some datas are very, if you look at these points, 1, these are very close to each other. Even if you look at these points, if you can see this 1 is very close to each other, but you will not find this 1 point anywhere else, or very few points here and there. But mostly these points are concentrated here only. But if you will look at this point, let's say something is yellow, what color you can call, whatever color is it, this is something light, you can say light green. So this represents 2. And you can see these are very highly separated. One point is here, one point is here. They are not very highly concentrated. So if you will observe this red points, this red point represents my 0. And again, this red point you can observe, this is highly concentrated. This is concentrated in this area only. You will not find a red point anywhere else. You will find all the red points at this particular, in this area only. But some points you will find are highly separated. Some points are dense. Likewise, so this is how the visualization gives me. This is how it also shows the relationship. If I simply play this, you can see how the visualization is getting. So this is what I actually wanted to show you. So now, each of these data points here corresponds to one of my xi. That is, each visual point that you are seeing here right now, each visual point that you are seeing here right now is corresponding to some xi values. And so this is, so this is, if you will look, if you will play this thing, you will see something, visualization, something like this, very different. What is this MDS? This is basically multi-dimensional scaling, correct? So you can read this and understand this. I have told you the crux of whatever is written inside this. And now, why I have shown you this, I just wanted to, let's say, motivate you with an, let me share this link in the chat. So this is basically the MNIST dataset, and you can download this dataset from C. Let me tell you this thing. This is a digit recognizer or digit recognizer dataset that you will find it on Kaggle. So if I will just move here to the this, can you see this? Here, this is a test.csv and this is a train.csv, and here you are getting the option of download all. So from here, you can download this dataset, test dataset and train dataset, right? And after you will download this, how you will download? By just if you click on this download button, you will this get downloaded. Now after downloading this dataset, now I am again coming back to my Visual Studio Code here, and since I have already downloaded this dataset, so what I am doing, before working on this dataset, I have to import some libraries. So these are the libraries which I need to import. That is NumPy, Pandas, and Matplotlib.pyplot. So these are the libraries. If you are not aware of it, so you have to know this. You can study these from my playlist. In the future also, we will be using this library very often. So I am importing NumPy, Pandas, and Matplotlib. So let's run this code. So these libraries get imported. Fine. Now, how to read the data? So there is some, pandas give us a method to read this data. pd.read_cv. And this is the path of this train data that I have just downloaded. I have given the path. Either I have to give the path, or if I will keep it in the same folder, then I don't need to give it the path. Fine. So since I am keeping it in a different place, that's why I am giving it a path. So this will what do? This will read this dataset train.csv dataset. So I am running this. And after that, I'm saving this in a this D0 variable. So now let's see what this D0 variable is. Let me just run this. Can you see? This is the MNIST dataset. If you will, this is a train. I'm using this train here in this dataset. There are 40,000 rows and 785 columns. If you will discover this, these are the columns. You can see. Can you see this, Mr. Rakesh?
Yes.
These are the columns. And the column is written a pixel level, then pixel 10, pixel 1, pixel 1, pixel 2, pixel 3. Likewise, there are 783 pixels, starting from 0 till 783. So total, there are 784 pixels. And every pixel, and this is my data points. That is, each of the image, handwritten image, is having 784 pixels, or you can say 784 features. And there are totals 42,000 rows and 785 columns. Now, the first column that you can observe, this is a level column. Here you will find the values from 0 till 9. You will not find anything else because this is my prediction. Because for any handwritten image, I want to predict whether that image belongs to 0, 1, 2, 3 till 9. So this is my level. I suppose this is clear. Now this is one thing is called D0. If I will just do this thing, it will give me for just for my convenience what I will do D0 dot head. What is this head do? It gives me the first 5 rows. Can you see? 0 to 5. 5 rows, 784 columns. Now, this level is my actual image or actual digit that I have told you. Now, so we know that we have 10 classes, right? Starting from 0 till 9. So 0 till 9, we have a 10 classes. But what thing is that this is my level. I want to separate this level from my this matrix or this data set. So for that, first I will do it. I will save this level inside some variable. So this is D0 and I'm saving this level inside some variable level, label level, correct? So let's save this. So when I'm saving this, if you look at